We try to have some samples which are labeled and some samples which are unlabeled. So it's a combination of these two supervised. So we have a training set which have few samples where the labeling is available, and there are samples where the labeling is not available. So we combine these two. We try to train the model with the labeled instances, and then we try to adapt this to the unlabeled instances. This we call it as semi-supervised learning. And all those cases like one-shot learning, zero-shot learning, transfer learning, so these you can take as examples of semi-supervised learning. And finally, the reinforcement learning, where we try to learn from feedback. So most of the time, humans learn with like a reinforcement learning, because we learn things from the feedback what we get, either the reward or the punishment. So we work on something, uh, and then we wait for some feedback mechanism. So if the feedback is good, we understand that what we have done is right, and when the feedback is bad, we understand that what we have done is wrong. So reinforcement learning is used in autonomous cars and even in robotics. So wherever artificial intelligence is playing a major role, we try to incorporate reinforcement learning, where the robotic machines has to learn from the feedback. Even chatbots will have this mechanism, because it asks you suggestions like whether the suggested material is useful or not. And if it is useful, if you say that the suggested material by the chatbot is useful, then it takes that the result what it has produced is right. And when you say that it was not useful, then it will try to correct itself. It will try to improve its knowledge base. And this is the overall process of machine learning. So you try to define a problem, what is there in the society, and we try to collect the data relevant to that particular problem. And then we try to pre-process the data with the help of feature extraction or feature selection or data transformation techniques. And then we move on to the splitting the data into training data and validation data or test data. And then we train the model, we fine tune the parameters, and then we come to evaluating the model in terms of some parametrics like accuracy, precision, recall, and so on. And then we deploy the model in a particular scenario where we are using it. Maybe it is a device which will automatically put off the fire, or it will automatically create an alarm when the temperature is going above a threshold. So in all these kind of systems, we can deploy it and we can see whether the system is doing well, and if it needs any correction or there is some troubleshooting needed, then it will once again go for maintenance. So we are talking about deep learning today, but among the number of techniques what is available in machine learning, say we have the decision tree algorithm, we have the naive Bayes algorithm, we have random forest classifier, we have support vector machines, and there are a number of algorithms like this. But artificial neural network, what is predominantly termed as ANN, is serving as a basis for deep learning. So we'll see some fundamentals about artificial neural network. So ANN is inspired from our biological neuron, which is taking the input in the dendrites, and it processes it and it gives some control signal as output. Okay, so the same way this unit here, it takes as input. Here we say, so see here, you're taking the inputs, and these inputs are given some weights, and it is summed up and it is given to an activation function, and this output is given as a final result. So this is the ANN structure, which is very, very similar to our biological neuron. So here it is taking input, and then the dendrites is carrying that to the different terminals. So this is ANN is one type of learning model which is inspired by the human brain, and it recognizes the patterns, make predictions, solve complex tasks, and it's also called as connectionist learning. And this serves as a foundation of deep learning. So originally, artificial neural network was used in image recognition, and now these basis is used in deep learning for natural language processing, self-driving cars, and all. The structure of ANN is like this. We have set of inputs, and these inputs are given to the input layer, and in between we have the hidden layer, and we have the output layer. So here in every edge you have the weights, and there is a compensation constant called as the bias also. A neural network, it is a connection of or it's a network which connects the input and output units, and in middle you have the hidden layer also, and every connection is characterized by a weight. In the input layer you have one unit for each value of the feature. For every value you have one unit in the input layer, and you have hidden layers. These hidden layers can be one or more, and when you increase this number of hidden layers we call the network as deep. An output layer, so this is where the final prediction is calculated from the input what is given from the input layer. So working of ANN, so it is tried to, even ANN can be used to learn the features, input features, and these features can be used for making output predictions. The important thing behind here is every feature is given a weight initially, and this weight is adjusted every time you are passing the input through the network. In every epoch, the weight is getting adjusted. So this is a fundamental equation like the regression equation or like the straight line equation, what we have learned in school, y is equal to mx plus c. So here there is only one independent variable x in the case of linear regression. But here, the case of ANN, you have multiple independent variables which is going to decide the value of Z. So for every independent variable, there is a weight associated with it, and we are trying to adjust this weight, or we are trying to minimize the error. So, and when you try to minimize the error in prediction, automatically the weights get adjusted. So the very important component here to uh, ensure the main purpose is the activation function. That is, this activation function takes the input and the weights, and it gives or predicts the output corresponding to this combination of input and weight. And there are different types of activation functions, which these functions we use in deep learning as well. Sigmoid function is a very important activation function. So whatever is the input, what your sigmoid function is given, it will squash the input to a range of 0 to 1. Okay, and then ReLU, it will output 1 if it is positive, and if the input is negative, then it will be outputting 0. Tanh function, also called as hyperbolic tangent, it takes the input and it will give the output in the range of -1 to +1. And softmax function, so it is fully of probability. Suppose if you're having a multi-class, it will it will give you probability, and the total, say I have three labels, y1, y2, y3. So this softmax function will say what is the probability of this particular instance to belong to y1, what is the probability of this instance to belong to y2, and what is the probability of this instance to belong to y3. And all this probability will always add up to 1. So to understand the activation functions deeper, so it's a diagrammatic representation of ReLU. So if you could see, for all the positive values, it is the value itself max of 0 comma x, that is x will be outputted, and if the value is negative, then it will be 0. ReLU will be outputting 0. And sigmoid function, so this is a function for the sigmoid activation function, and it squashes the input to the range of 0 to 1. So this is a softmax example what we saw, that is it produces scores like this, takes scores like this, and it predicts probabilities. That is, to have a score of 2, the probability is 0.7, to have a score of 1, the probability is 0.2, and to have a score of 0.1, the probability is 0.1. And you could see that all the three possibilities will always add up to 1. So this is the softmax function. Tanh function, it takes the input, converts it and into a value which is in the range of -1 to +1. So here we are trying to train the ANN to determine the optimal weights and optimal bias values, which will minimize the error. So the loss function is calculated using either mean squared error or cross entropy loss. And to iterate, we importantly use a function algorithm called as backpropagation. So in every iteration you try to find out the error, say the mean square error between the actual target and the predicted target, and this error is propagated backward. And this change gradient, we can call it as change. So this error will be propagated back to adjust the weight. Now the weight are adjusted, and um, once again the input is fed back. If the error is again there, then again the error is propagated, and once again the weights will be adjusted. So here the learning rate is a very important parameter, because that will adjust the rate at which the weights are adjusted. So these are the different types of artificial neural network. So the first and foremost, the very basic ANN, which is the feed forward network. And there is another type, convolutional neural network. This then another one is recurrent neural network. And finally today we talk about an ANN called as generative adversarial network. Deep learning. So deep learning, it is a subset of machine learning. It involves neural networks which has many layers. Deep neural networks is the common term we normally use instead of deep learning, because it has its base on artificial neural networks. And the only thing is, when we are talking about ANN, with respect to machine learning, ANN has a very important problem. It is very complex to build the network. When the size of the data set increases, ANN takes too much of time. So now when I was doing my research, naive Bayes and other kind of algorithms, support vector machines, they run very fast in my system when compared to artificial neural network, because it involves a lot of connections, a lot of weights and bias which needs to be updated. So in the case of images, I was working on only data, that is row column format, whereas tabular data. Whereas when you people work on images, ANN wants the image to be converted into features. That is, the features has to be extracted first, and then only the input can be fed into the ANN, because ANN cannot directly process the images as pixels itself, because the number of pixels, it's very impossible to be handled by an artificial neural network. But deep learning is a blessing in the sense, so here I've given us curves of dimensionality. So when the dimension of the given data set increases, artificial neural network suffers a lot. It cannot make predictions, it cannot work properly. Your systems might hang, but deep learning came as a savior in handling the images as images itself, or handling the signals as signals itself without making any feature extraction. And in this process it will learn the features in a hierarchical manner, and it's also applicable for large data sets, and it is very powerful computationally. Deep learning is very powerful because of GPUs. So this is a brief history of deep learning. So artificial neural network started with in 1943 with the invention of McCulloch's neuron. So McCulloch and Pitts, they invented something called neuron. So this is the first and foremost development in the area of deep learning. And then the perceptron is developed by Frank Rosenwald in 1958. And John Hopfield, he invented the Hopfield network in 1982. And in 1989, CNN was developed by Jan LeCun, and RNN was developed by Jurger and Sepp. The GPUs was developed in the year 1999. Actually, the invention of GPU is what is playing a major role in today's advancement. Maybe it is ChatGPT or any other kind of generative models what we are using today. It's all because of this one invention of GPU. Artificial intelligence research suffered a lot after 1980s, because the hardware was not supporting the algorithms of artificial intelligence. And this particular invention in hardware, like the graphical processing unit, which made it possible for even our systems to run deep learning projects. And in 2014, GAN was invented by Ian Goodfellow. He's also a very good researcher, and he has written a book on deep learning, which is textbook for a number of courses on deep learning. And in 2017, the Transformers was developed, and Google was playing a major role in that development. And in 2020, OpenAI developed and released the GPT, convolutional neural network. So, to have a brief introduction about CNN, CNN is a type of deep learning model. If you could understand CNN, then or you could make a lot of research. So, this CNN models is primarily used in these two types of data, that is images and video. But today we see CNN is also used in tabular kind of data, signals, audio, etc. And they extract the features and make predictions. Here you have different types of layers, that is the input layer, convolution layer, pooling layer, flattened layer, fully connected layer, and the output layer. So this fully connected layer we also call as a dense layer. So here, this is the structure of CNN. We have the input data, we have the convolution layer, which involves the activation functions, followed by the pooling layer, which can be a max pooling layer or an average pooling layer. And then after flattening, we have the fully connected layer and the output layer. So layers, input layer, it is going to accept the raw data. So as we all know, it is going to accept the raw data. The raw data is every unit is going to be every value of an attribute. That is, suppose if your attribute has three values, that is three different values in the domain, then there will be three different unit which will be created. And you have 10 attributes, each 10 attribute is having three values in its domain, then you will be having 30 units in the input layer. And then a particular unit will be set if the particular value is there in a particular row. Okay, hope it's understandable to you. And then in the conventional convolutional layer, which is a mathematical operation, or very simple terms, I'll say that it is a filter. People who have been in image processing, who have used number of filters to remove the noise, to identify the edges, to make blurring enhancement, with the help of filters. This convolution operation is nothing but a filter or a kernel which is going to convert the input or transform the input. So it can be, the filters can be used to detect the edges or to detect the textures or to detect the shapes, etc. So this filter moves over the input and it makes some mathematical operations like multiplications or additions to produce the final result. So this convolution operation can be considered as a feature extraction process. So it makes extraction of local features, and the output of CNN is a feature map. And every convolution layer can have multiple filters as well as multiple channels. So that's why normally we consider this data as tensor. And pooling layer, so here we are going to try to reduce the feature maps, the size of the feature maps, or we are trying to So, yes. So we are talking about kernel, and we were discussing about stride. So stride refers to how much you are going to move the filter. So here, when you want to increase the size of the output feature map, or we want to have a very small feature map, or we want to have a large feature map, based on that we can either increase, you can make the slide value according to the feature size what you want. Say for example, if we set the stride as 1, it moves through every pixel, 1 pixel at a time. It will move from one pixel to another. If you set the stride is equal to 2, it will skip 1 pixel. And if you set the stride is equal to 3, it will skip 2 pixels, and so on. When it skips 2 pixels, okay, that is when the stride is very large, it makes a very small feature map. The stride will try to reduce the size of the feature map. And when we have a very small stride, that is in the case of stride is equal to 1, or stride is, yes, stride is 1 is a basic thing. So when we have the stride as 1, we'll be having a larger feature map, because we will be having many movement over the input image. When we have very less movement over the input image, we have a very smaller feature map. And when we move through every pixel of the input image, we will be having a larger feature map. Padding, again, this will also decide the size of the output feature map. So if we add padding, if you want the original size of the image to be preserved in the convolution layer also, then we can add padding. So when you add padding in the CNN configuration in Keras or other kind of CNN networks, we can set the padding is equal to same. If you set padding is equal to same, then it will automatically makes the output size remain same as the input size. Okay. So if you instead, if you give padding is equal to valid, it means it will not add any padding, and the output size will be having a reduced size. An activation function, so this we have already discussed. Either the activation function can be relu, or the activation function may be sigmoid or tanh. But in the case of CNN, the most preferred activation function is relu. So benefits of CNN. So CNN helps to learn the localized features, because it makes the feature extraction based on localized some 3x3, 5x5 matrix kind of filters will be operating over the entire image. So we call these features what is extracted as localized features. And since we are using the same filter across the entire image, we say the parameters are shared. It is not many parameters we are going to involve. We are going to have a reduced set of parameters. And we say that CNN is making the early patterns to be detected in the first few layers, and as we go deeper, or when we increase the number of iterations, the complex features are detected. So we say that is the hierarchy. And uh, so irrespective of the images is previously before CNN, the ANN networks, so suppose if there is a 1, so say there is a 5, the 5 is tilted, it is translated, it is having a rotation. Now the model will not be able to identify that as a 5, but a human can recognize 5. In any position you write a 5, the human will be able to say that it is 5. Okay, but the networks were failing in this case. But CNN has an important benefit, that it will, even if you make some translations or shift over the input image, even then the object can be detected irrespective of the position. And CNN architecture. So these are some of the very famous CNN architectures. LeanIt, it was invented in 1989 by Jon Legan. So this was the first CNN which is used for detecting the handwritten digit recognition. So this is the first time where the handwritten digit, computer can recognize computer generated thing, but humans write in a different way. You might write 2 in a different format, I might write 2 in a different format. Okay, but computer should recognize this. So this is a very big advancement in the artificial intelligence, the creation of LeanIt and AlexNet. It was developed by Alex and its colleagues, and they won the ImageNet competition in 2012. And VGGNet is another famous network you all would have heard, and this is 2014, where Karen and Andrew they have invented this VGGNet, which uses very very small filters, but they have a number of layers, 16 to 19 layers. And then ResNet. So this is also invented in 2015 by he and other colleagues, and here they went up to 152 layers actually. So they had very very deep networks and applications. So here it is used in image and video recognition. It is widely used in medical image analysis. It is used in autonomous vehicles, natural language processing, and recommender systems. So generative models is what we are talking widely today. The AI models can be categorized into two: discriminative models. So till now, whatever I was discussing, saying that I'm trying to predict what is a class, I'm trying to group something that is using unsupervised learning. So these tasks are called discriminative tasks. I try to identify the difference between two classes and I separate them with their boundary. But generative models is I try to understand the data and I try to produce more data which are similar to that. I understand the voice, the pitch, intensity of a person, and now we have generative models which are speaking as if the person who's deceased, say a person is no more, but there are audio generators which can exactly mimic the voice of the person who's no more. Okay, similarly, the GAN networks are generating images, and there are different types of models which are generating videos, audio, images, etc. So this is a difference between, and even generative models. It talks about, yeah, these are all the different data what are generated. They generate text, they generate audio, they generate video files, they generate images, and even there are code generator. Today our students are doing a lot of stuff because they have code generators. If you ask a black box AI or if you ask ChatGPT, they are able to provide code. They are able to provide codes uh, on its own. Okay, so generative models, it's also neural networks. They are trying to identify patterns or structures based on um, the existing data, what we have given. And whenever you're giving a correct prompt, the generative model will be able to generate contents for you. So here, generative AI, the important advancement is with the invention of or development of ELISA, which is a chatbot which is developed in MIT by Joseph Weizenbaum. And in 1999, the GPU was invented. So this is also playing a major role in generative AI. And Google has autocomplete option. That is, once you enter a particular word, it will automatically fill the other text. So this you could see in Google search engine as well as in Gmail. So this is an important advancement which has happened in 2004. In 2013, the variational autoencoders were invented, and in 2014, the generative adversarial networks were developed. And once again, these things I have already discussed. So we'll move on to the applications of generative AI models. So generative AI models is used for image generation, text translation, synthesis of data. That is, mm, I don't have data for a particular problem. In COVID, we're realizing there is no data for COVID. So people wanted to have more data on that. So these generative models will help to generate data on a particular situation. So people are today making drug discovery for complicated diseases, but we have only few patient cases, and maybe don't have sufficient data. Now you can use this generative AI models to generate similar kind of data, synthetic data, and they can generate audio, they can generate video, and they can also generate code. So here in the case of text, they can make translation, they can make summarization, etc. So these are some of the four different deep generative models. It is generative adversarial networks called as GANs, which helps to develop images. Okay, and transformer-based models that includes GPT, the Chat GPT model, what we are seeing today. So it makes translations, it makes text summarization, text generation. Okay, so you're asking some content. your ChatGPT is generating content on its own. So these are all based on the transformers and variational autoencoders. So these can generate images as well as they help to detect the anomalies, that is unexceptional data, unusual behaviors. So these can be detected with the help of VAE, that is variational autoencoders. Diffusion model, so this also helps to generate images and videos, but here they use something called noise. To the original image, they add noise and they try to learn uh, how to generate new images or video from the original. So the darker side is we today we see a lot of pseudo images, deep fakes, that is fake images which are not actually human beings. So this will go to a lot of threat to the security of a nation or security of other people, and we are losing control. When AI takes control, human beings are losing control. And today, your foundational model is trained on large amount of data, what is available in the World Wide Web. And we don't talk about intellectual property. A document is an intellectual property of somebody, but the AI model is trained on that also. So we don't know what is available for ChatGPT and what is not available, and the privacy will be a biggest issue. So these are all the darker sides. And to summarize, we have discussed about machine learning, which is a subset of AI, and machine learning helps to create knowledge to the machine. And deep neural networks or deep learning is the subset of machine learning which will address the problem what machine learning had, like curse of dimensionality. And CNN is widely used in image recognition and natural language processing. So we have also discussed about some of the latest generative models such as GAN, BAE, transformers, and diffusion model. Yeah. So normally we think that AI is future, but we have to realize that AI is not our future and it is our present. Thank you once again for the valuable opportunity you have given to me, and I'm extremely sorry for the technical glitches what we had in the beginning. Once again, I thank the organizers for giving me such a wonderful opportunity to present the session before you all. Thank you so much. So, if you have any questions, I'll be listening to your questions.
Okay, ma'am. Thank you for your valuable presentation. Thank you, ma'am.
Thank you, sir. Thank you.
Thank you. Thank you, ma'am. Good afternoon to all. It's my great pleasure to extend a hearty welcome to each one of you present here at the FDP program on research challenges and issues in trends in data science and machine learning. It's my pleasure to invite Dr. G. Sundari to share his valuable insight. She is currently working as Assistant Professor Senior Grade in Department of Computer Science and Engineering, National College of Engineering, Kovilpatti. She has 21 years plus experience in teaching and expertise in data structure, artificial intelligence, and Python programming. She published 11 journals and 15 conferences. She is a life member of ISTE. She received 3 Golden Elite in NPTEL course in area of data science and Python. She is also received a certificate of appreciation in NPTEL Discipline Star. We look forward the valuable insights you will share during the session. I encourage all the participants to actively engage in this program as it offers a great opportunity for growth, learning, and professional development. Thank you, and I hope everyone has enriching and productive session ahead. Thank you, ma'am. Now start your session.
Thank you so much, sir, for your introduction. So just a minute, sir.
ஷேர் பண்ணுங்க. இன்னைக்கு ஃபஸ்ட்டு நீங்கள் எங்கே இருக்கு கிளிக் கொடுத்து ஷேர் ஷேர்
Hello? Hello? Hello?
Yes, ma'am.
Can you able to
Yes.
use the PPT?
Yes, ma'am.
Okay, shall we
Yes, ma'am.
proceed?
Visible.
Ah,
Okay, ma'am.
okay. Okay, first we will see the machine learning introduction. Actually, machine learning is a branch of artificial intelligence. All of you know what do you mean by artificial intelligence? Actually, it is a branch of computer science and it makes a computer to mimic as a human being. So, machine learning is a part of artificial intelligence. It provides machine the ability to automatically learn from the data without the explicit programming. So, it learns from the data and past experiences to identify the patterns and make prediction with minimal human intervention. So it won't need any explicit programming. It will automatically learn from the data as well as from past experiences. So these are some of the real-time applications of machine learning. Computer vision. Actually, the computer will able to analyze the images as well as videos. Some of the example is face recognition and digit recognition, object recognition. Some of these are example for computer vision. And next is recommendation system. Actually, Netflix, Amazon, all are example for recommendation system. Based on the human preferences, it will suggest the product or content. And next is predictive analytics. Based on the previous data, it will predict the future. And next is fraud detection. In finance, it will analyze the transaction and identify which are all the fraudulent transactions. And in the healthcare, some of the examples are medical image analysis and disease prediction. These are examples for healthcare. In autonomous vehicle, the automated car is an example for autonomous vehicle. It uses reinforcement learning and it will take real-time decision based on the environment situation. And next is cyber security. It will analyze the transaction and it will identify the breaches in the security. And natural language processing, it will enable the computer to understand and interpret with the human language. And next is robotics. In robotics, the object navigation is done with the help of machine learning. So these are some of the current real-time applications of machine learning. And this is the machine learning life cycle. Actually, these are the steps involved in any machine learning algorithm. Actually, first step is to identify the business problem. Identify the business problem means what is the input we are having and what is the expected output. These form the identification of the business problem. After identify the problem, we need to collect the necessary data to solve the problem. So these data may be collected from various resources. The resources may be file or it may be a database or it is from internet or mobile devices. After collecting the data is in different formats because they are collected from different resources. So we have to follow the data preparation. Data preparation means we have to make all the data in common format and some of the data may be missing. So we have to handle those missing values and some data may be have outlier. So we have to handle the outlier also. So after data preparation, after data preparation, we are having the step exploratory data analysis. From the data, we have to identify the relation between those data. Which data depends upon which data. So that is called exploratory data analysis. This can be done through data visualization. Data visualization and through statistical measure, we can able to done exploratory data analysis. So we have to identify the relationship among those attributes. Which input attributes will have the effect on output and what are the relationship between one input attribute with another attribute. So this comes under exploratory data analysis followed by selecting the algorithm or model. After the EDA, we have to choose model. Actually, there are different types of machine learning model. Among each algorithm, we are having different type of model. So based upon the application, we have to choose any one of the model. After choosing the model, feature engineering follows. Suppose we have already some of the features means we have to create new features using the feature engineering concept. So some of the feature may be irrelevant to the problem. So those features are eliminated and some of the feature may be derived from existing features. So followed by feature engineering, we have to train the model. The data set is divided into two parts, training data set as well as testing data set. Usually 80% of the data set is assigned for training data set. Using training data set, the model is trained. Trained means it has to identify the relationship between the input as well as output. Actually, training the model means it will identify the mapping function between the input and the output. So the output of the model is it is a mapping function. After training the model, the validation takes place. During the validation, the performance is evaluated. The performance is not acceptable, then we have to tune the parameters so that until the performance is accepted. So during the validation, we are tuning the hyperparameters. After validation, testing follows. Through performance measure, we can evaluate the performance of the data set. If the performance is acceptable, then the particular model is deployed in real time. After deployment, if there is any issue, the maintenance follows the deployment. So these are the steps in machine learning life cycle. Identify the problem, then data collection and preparation, followed by exploratory data analysis, followed by selecting the model, feature engineering, training, followed by validation and testing, model deployment, and maintenance. All of you able to follow? Hello?
Yes, ma'am.
And these are the types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Actually, supervised learning is a fundamental approach of machine learning. Here, the algorithm learns from the labeled data. Actually, labeled data means we are giving input as well as output to the algorithm. The aim of the algorithm is it will learn the mapping function. From the input and the output, the algorithm learn the mapping function during training. So algorithm learns from the labeled training data to make prediction. And two types of supervised learning are: one is classification and another one is regression. In classification, the output is a categorical data, whereas in regression, the output is a continuous value. So in classification, the algorithm assigns label to the input based on its learned pattern. So each input is given along with its label. Here the label is the output. So in classification, we are giving input as well as output. In regression, it involves predicting the continuous values based on the various features. So in the regression, the input is a set of features and the output is a continuous value. And the example for classification is, suppose the classify the mail either it is a spam or not. And in regression, to predicting the house price or to predicting the stock market value, these are all example for regression. So the regression output is a continuous value, whereas in classification the output is a categorical value. And these are some of the algorithms under supervised learning. Linear regression. Linear regression, the output is a categorical value. Based on the features, it will predict the categorical value. Logistic regression, the output is either true or false. Actually, it is a binary output value. Logistic regression has only a two output, either it is true or false, or 0 or 1, and so on. And decision tree, this model is learned from the tree. In this tree, the intermediate nodes are act as a decision, and the leaf nodes are the outcomes. Actually, it is a tree-like structure. Use this model is a tree-like structure. In this, the intermediate nodes are the decisions, and the leaf nodes are the outcomes. And next one is support vector machines. In this model, actually, it is used to classify different set of classes. Here to classify, we are choosing the hyperplane. The hyperplane in the two-dimensional or three-dimensional space, we are drawing the hyperplane. The hyperplane classify the data into separate classes. And next is random forest. Actually, it is a expansion of decision tree. In the random forest, we are using several decision tree, and we are aggregating the result of those several decision trees. And next is k nearest neighbor. K nearest neighbor is also one of the classification algorithm. It compares k nearest neighbors and choose among the best. And next one is naive Bayes classifier. It is based on Bayes theorem. Now we will see how the supervised machine learning works. Here the model is provided with a training data set which include the input data, that is the features, and the corresponding output, that is the label. So we are giving input data along with the output data. So input data is the features and the output data is a label or a target variable. Here the learning process
Excuse me, ma'am,
takes place.
excuse me, ma'am, kindly change your slides, please.
Okay, I am changing, but it is not reflecting. Hello? In which
Ma'am,
slide
only
you are?
the real-time applications can be displayed.
Okay. Now is it visible? Now the slides are changing or not?
Real-time application slide can be visible, ma'am.
It is still in application.
Real-time applications.
Okay, just a minute.
Initial slides, ma'am.
Okay, just a minute.
Ma'am. Ma'am.
Uh, just a minute, sir.
Okay.
Actually, I am changing the slide. Now, which slide you are viewing? Still in application? Hello?
Hello, ma'am. Yes, ma'am. Slide view, ma'am. F5 press பண்ணி பெரிய screen வைங்க, ma'am.
Actually, slide show தான் sir கொடுத்திருக்கேன் already.
Okay, okay, ma'am.
Now I am in machine learning
Real-time
life
application
cycle.
slide can be
Can you
displayed.
able to view the machine learning life cycle?
No, ma'am. Only the real-time application slides can be visible.
Okay, just a minute, ma'am. Hello, sir. Hello? Hello? Hello?
Yes, ma'am. Now the type of machine learning can be
Okay,
visible,
okay,
ma'am.
okay. Now
Ma'am.
now it is changing.
Thank you,
Hello.
ma'am.
Okay, now can you able to view the changes?
Thank you. Yes, ma'am.
Supervised learning. Hello?
Hello. Yes,
Yes,
ma'am.
ma'am.
Yes,
Now,
ma'am.
Yes, ma'am.
now is
Yes,
it
ma'am.
visible? Okay.
How supervised exams for
Now,
the supervised
how supervised machine learning works?
machine learning works? Yes,
Okay.
ma'am.
Okay.
Thank you.
So the model is provided with a training data set, which include the input data and the corresponding output data. Here the input data is the features and the output data is the corresponding label. So the learning process takes place like this. The algorithm process the training data and it will learn the relationship between the input feature and the output label. For example, suppose the input features are assume the numbers 1, 2, 3, 4, 5 and 6 and the target values are 1, 4, 9, 16 and so on means the mapping function is it will find the square of the given value. So the input is a set of number and the output is a square means it will learn the mapping function as square. So similarly, it will learn the relationship between input features and the output labels. So the output of the training data is it will learn the mapping function. Then during the validation, it will tune the hyperparameters. Suppose the performance is not up to the level means we can tune the parameters so that the performance will be improved. So after the validation, testing takes place. It involves feeding the model with the new unseen data. In the training section, we are giving some data. During the testing session, we are giving some new unseen data and evaluates its performance. If it will predict the output as correct means the model is ready to deploy. Otherwise, we have to improve the model either through giving several additional example, we can improve the performance, or through hyperparameter tuning, we can improve the performance of the model. So whenever the performance is accepted, the particular model is ready for the deployment. And actually the data set is divided into two parts, 80% training and 20% for testing. And this is a diagram. Actually, in the diagram, for the algorithm, the input is given. Here the input means the image along with the label. So here input as well as output, both are considered as input. And the output of the algorithm is a mapping function. Here the logic means it is a mapping function. So in the next diagram, the input is given to the mapping function so that it will produce the output. So the output of the algorithm is a mapping function. After training, the model will learn the mapping function. Then the mapping function is, for the mapping function, the input is given so that the input will predict the output. If there is any difference between the output we have received and the actual output, and the difference is referred as bias or error. Actually, this is an example data set for a supervised machine learning. Actually, there are two types. One is classification and another one is regression. This is an example for classification. Here, user ID, gender, age, salary. These are all input and the purchased column is a output. So, in the training data set, they have input as well as output values. So, this data set is used for training. So, it will learn how the input is converted into output. So, it will learn the mapping function. So next time if you are giving the input features, it will automatically predict the output, purchase output either 0 or 1. So in the classification, the output is a categorical value. And this is a data set of the shopping store. It is useful in predicting whether the customer will purchase a particular product under consideration or not based on his gender, age and salary. So depending upon the gender, age and salary, it will predict whether he will purchase the particular product or not. And this is an example for regression. In the regression, temperature, pressure, relative humidity, wind direction. These are all input features and wind speed is a output feature. Here the output is a continuous value. Data set that serve as a purpose for predicting the wind speed based on the different parameters. Here the output depends upon several parameters. So this is example for multiple linear regression. If the output depends on single input mean it is referred as single regression. If the output depends upon several input feature mean it is referred as multiple regression. The next type of machine learning algorithm is unsupervised learning. In supervised learning, we have given labeled data as a input. That means we are giving input as well as output. That input will act as a teacher in the supervised model. Here we are giving the output will act as a teacher in the supervised model. Here we are only giving the input. So it is referred as unsupervised learning. So unsupervised learning focusing on extracting patterns from unlabeled data. Here the input is unlabeled data, so it will focus on extracting the pattern. So it will extract the pattern and group the patterns similar uh, which are in similar form. So unsupervised machine learning analyze and clusters unlabeled data set using machine learning algorithm. So it will analyze the data and group those data which are having similar features. So there are mainly three types of algorithm in unsupervised learning. One is clustering, association rule mining, and dimensionality reduction. In clustering, it group the unlabeled data into cluster based on the similarities. So based on the feature, it will group the unlabeled data into cluster. The data with similar features are grouped into one cluster. One of the example is k-means clustering algorithm. Here it will group the data into k number of clusters. And next is association. Actually, it is a rule-based machine learning technique that find out some very useful relation between the parameters. It will identify the relationship among those products. And the example algorithm is a priori algorithm. And next one is dimensionality reduction. Actually, it is a process of reducing the number of features. If the features are vast, the model become too complex. So we are removing the some of the irrelevant features. So it is a process of reducing the number of features in a data set. At the same time, we are preserving the information which is essential. Next, how supervised learning works. So here there is no labeled data. So it will analyze the unlabeled data to identify the pattern and the relationship. So the data is not labeled with any predefined category or outcome. So the algorithm must find this pattern and relationship on its own. And it is a powerful tool for exploratory data analysis. We have already said the exploratory data analysis, the purpose of EDA is to identify the relationship among the features. So the unsupervised learning is useful for EDA. And this is example for unsupervised machine learning. Here we are giving only input, there is no output. So input are the customer ID, gender, age, annual income, and spending score. So it will identify the similar patterns and group those similar pattern into single cluster. So the data is corresponding to mall data that contain information about its client and subscribe to them. Once subscribed, they are provided a membership card and the mall has complete information about the customer and is every purchase. So based on the input, it will classify the customers into different categories. It may either categorize based on age or it may categorize based on the annual income and so on. And third type of machine learning is reinforcement learning. So it is a dynamic area of machine learning. Here we won't give the data as a input. It interact with the dynamic environment in order to reach the goals. Actually, this is a diagram. Actually, the agent through the action interact with the environment. As a result, the environment either provide the reward or penalty. If it provide a reward means he is going in the right direction, so he will continue the same direction. If there is a penalty means he is doing the wrong thing, so he have to rectify himself. So based on the reward and penalty, it will learn from trial and error method. So it focused on how agents are to take action in an environment to maximize the cumulative reward. So it learning through trial and error, making it particularly suited for complex decision making problem. So this type of learning is useful in complex decision making problem. With the help of the reward feedback, the agent are able to learn the behavior and improve it in the longer run. Here the feedback reward is known as the reinforcement signal. Up to this, all of you able to follow?
Yes, ma'am.
Is it clear up to this?
Yes, ma'am.
Okay. And this is the example for supervised learning. There are two types of supervised learning we have already seen. One is regression and another one is classification. Now you will see linear regression. So it is a basic algorithm to understand the concept of ML. In the linear regression, it finds the relationship between one or more features and the continuous target variable. So the one or more features are called independent variables. So these are the input features, and dependent variable means that is a output feature. So the output feature here is referred as dependent variable, and the input features are referred as independent variable. So based on the input feature, the output feature varies. So the output feature here is referred as dependent variable. So based on one or more features, the output feature or target variable varies. When there is only one input feature, then it is called univariate linear regression. Otherwise, it is called multiple linear regression. In this diagram, the right hand side graph, it will show univariate linear regression. Here the price of the house depend upon the square root. The x-axis is square root and y-axis is price. So the price depends upon the square root of the area. From the graph, we can easily determine the price of plot of the given area. For the given area, we can able to predict the price. But what if we want the price of the plot with the area 7 into 1000 square feet? Actually, the graph consists of up to 3000 only. But actually, we want to know the price of 7000 square feet. So there is no such data point in the graph. So we have to predict the price for 7000 square feet. So here we will try to find the relation between price and the area of plot. If the plot of n pairs of data for an experiment appear to indicate a linear relationship. Actually, from the previous graph, we already learned there is a linear relationship between the square feet as well as the price. If the square feet increases, the prices also increases. That is a linear relationship between the input and output. So by observing this pattern, we can have our hypothesis function as below. F of x equal to w into x plus b, where w is a weight and b is a bias. For different set of w and b, there can be multiple line possible, but for one set of value, it will be close this pattern. And the error E of I is represented as yi minus y equal to f of xi minus y. F of xi means actually we are predicted some value, that is f of xi, and y is a expected output. So there is a difference between the received value and the expected outcome, that is referred as error ei. And the next type of supervised learning is SVM. We are having several algorithms for supervised learning for classification, but we will see one of the example, that is SVM. SVM means support vector machine. Actually, this is a dimension. It may be a 2D space or a 3D space. A hyperline is drawn so that the data points are classified into two categories. So support vector machines are the powerful yet flexible supervised machine learning algorithm. It is used for both classification as well as regression, but generally it is used for classification. So it is basically a representation of different classes in a hyperplane in a multi-dimensional space. Actually, this is a multi-dimensional space, and the hyperplane that will divide the data point into different set of classes. So the hyperplane will be generated in an iterative manner by SVM so that the error can be minimized. And the main objective of the SVM is to divide the data set into classes to find the maximum marginal hyperplane. Actually, there are 3 lines, 2 red lines, and in between there is a line. The 2 red lines, they are the margin. The aim of the SVM is to maximize the margin. It can be done in the following 2 steps. The margin can be maximized by doing these 2 steps. First, the SVM will generate hyperplanes iteratively that segregate the classes in a best way. So first we have to generate a several hyperplane. Then it will choose the hyperplane that separate the classes correctly. Among those hyperplanes, we have to select one of those hyperplanes that separate the class correctly. So that is the main objective of the SVM, to find the maximum marginal hyperplane. And these are some of the key words used in the support vector machine. Support vector means data points that are closest to the hyperplane. It is called support vectors. Okay, in this diagram, the points which are in the red line, uh, those are considered as support vectors. These 3 blue dot and 3 one green dot, they will refer as support vector. So data point that are closest to the hyperplane is called support vectors. And hyperplane, the hyperplane will divide the space into two type of classes. So it is a decision plane or space which is divided between a set of objects having different classes. And margin means it may be defined as a gap between 2 lines. Actually, it is a gap between 2 red lines on the closest data points of the different classes. Large margin is considered as a good margin and small margin is considered as a bad margin. So the objective is to maximize the margin. And another term is SVM kernel. Actually, the SVM kernel is implemented with kernel that transform an input data space into required form. Actually, it translates the low dimensional data space into high dimensional data space. In simple word, it will convert the non-separable problem into separable problem. So thus it makes SVM more powerful and flexible and accurate. Hence it converts a non-separable problem into separable problem. It is more powerful, flexible and accurate. So we have seen 2 examples for supervised learning. One is linear regression and another one is SVM. Next we will move on to example for unsupervised learning. So K-means clustering is example for unsupervised learning. So K-means clustering is widely used unsupervised machine learning algorithm for partitioning a data set into specified number of clusters. Here the number of clusters is denoted as K. So the algorithm tries to group similar data points together by minimizing the variance within each cluster. It will minimize the variance within each cluster and maximize the variance between clusters. Minimize the variance within the cluster and maximize the variance between clusters. And left side diagram is before applying the K-means clustering algorithm, and the right diagram is after applying K-means diagram. Here the K value is 3, so it will have 3 clusters. And the K-means clustering algorithm. First we have to choose the number of clusters. Then for each cluster we have to select a centroid. So randomly select the centroid point for each cluster. Then assignment. Assign each data point to the nearest centroid based on the distance metric. Actually, we have to find the Euclidean distance between the center point and the taken point. Based on the distance, it is placed in any one of the cluster. Whichever distance is very less, it is placed in the particular cluster. So assign each data point to the nearest centroid based on the distance metric. This form K clusters. Then update the centroid. Suppose if you are attaching one point to the particular cluster means, again we have to find the centroid by taking the mean of those points. So after all points have been assigned to a cluster, recalculate the centroid by taking the mean of all points in each cluster. So after each iteration, after you are adding every point to the particular cluster, you have to take the mean to find the centroid. Then repeat the assignment and update step until convergence. Convergence means after iteration, if there is no change in the centroid value, it will become converged. It means it is already converged. So repeat the assignment and update steps until convergence. Convergence occurs when the centroid no longer change significantly. Okay, up to this, all of you clear? Hello?
Okay, ma'am. Okay, ma'am.
Shall we proceed?
Yes, ma'am.
Okay, next we will see challenges of machine learning algorithms. So these are some of the challenges faced by the machine learning algorithm: data quality and quantity, overfitting and underfitting, model interpretability and transparency, scalability and computational efficiency, generalization to new data, hyperparameter tuning, real-time decision making, algorithm selection, and resource constraints. How we have to address these issues? So first one is data quality and quantity. Actually, due to insufficient data, this or noisy or biased data or data inconsistencies, it will occur due to insufficient data or noisy or biased data and data inconsistencies. So how to address these issue? Data augmentation. So data augmentation, we using the data, uh, we are performing rotation, flipping, scaling, or other transformation to the existing data, so that the data set will be increased. And data cleaning, remove the duplicate and handle missing values and correct error. By doing this, we can clean the data. If the data is not perfect, means we are remove the data. Crowdsourcing means we are getting data from different sources, different online sources, so that we can increase the amount of data. Next is transfer learning. Transfer learning means we are using the pre-trained model, allowing a model to leverage knowledge from larger data set. Actually, initially the pre-trained model used a small data set. Now we are using the same pre-trained model for the larger data set. Then synthetic data generation. The data is not sufficient, means we are performing synthetic data generation through generative model. So we are using a generative model to enhance the data quantity and diversity. And next is overfitting and underfitting. The overfitting, if the model is too complex, it will result in overfitting. It will learn uh, noise along with the data. It will capturing noise instead of underlying data. Is a result for, it is the cause for overfitting. The cause for overfitting is while it learn the trained data, it will also learn along with the noise. So that is the reason for overfitting. Underfitting means if the model is too simple, the performance is not that much sufficient. It is the reason for underfitting. In overfitting means it will work well for the trained data. Overfitting means it will work well for the trained data, but when it will see the unseen data, the performance is degraded. The reason for this is it will learn training data along with the noise. In underfitting, the model is so simple, so it can't predict the predict the output correctly because the model is too simple. So the solution is cross validation. Actually, the validation part is used for tuning the hyperparameters. So here use k-fold cross validation to tune the model and assess the performance of unseen data. K-fold cross validation means suppose we are having, for example, we are assume we are having 100 rows Actually, it is divided into 10 clusters, each consisting of 10 rows. So first 10 rows are kept for testing, and remaining 90 rows are used for training. Similarly, during each iteration, the next 10 rows are considered for testing, and rest of the 90 for used for training, and so on. That is called use k-fold cross validation. So using cross validation, we can address the issue of overfitting and underfitting. Then regularization. It is a generalization technique to reduce the bias. It is a generalization technique to free from overfitting. And next is the ensemble method. Instead of using single model, we are combining the result of multiple model and aggregating those results. That is referred as ensemble method. The examples are random forest, gradient boosting, bagging. These are all examples for ensemble method. Instead of getting result from a single model, we are combining the results of several models and aggregating those results. It will improve the performance. And next is model complexity tuning. Adjust the model complexity by changing the number of features, layers, or hyperparameters. So here we are tuning the hyperparameters. Similarly, try to change the number of layers and the number of features. And early stopping. Suppose if there is no performance improvement, means for the several iteration, if there is no performance improvement, mean instead of going proceed with, we are stopping early. This is early stopping. In iterative methods, stop training when performance on the validation set starts to degrade. That means if there is no performance improvement, we stop the training. That is referred as early stopping. Then data augmentation. Data augmentation means the in the underfitting, the model is so simple because lack of the training example, the model is too simple. So using data augmentation, we will increase the size of the data set, so the model can learn better. And next is model interpretability and transparency. Actually, in the deep learning like models, it will act as a black box model. That means we can't able to understand what is going inside the particular model. So difficulty in understanding how the model makes decision, especially for black box model like deep neural network. So the solution is explainable AI. That means we can interact with the particular model, and we can get the idea behind the particular model. That is the concept of explainable AI. We can interact with the model and getting the needed details. This can be done through these techniques, SHAP and LIME. And model simplification. So use simpler, more interpretable models like decision tree or logistic regression when interpretability is crucial. And next is scalability and computational efficiency. This is another challenge. Scalability means to expand the model, and computational efficiency means how to improve the performance in the way of space complexity as well as time complexity. How will you improve the efficiency? So this is one of the issue. The solution is distributed computing. So using the parallel data processing and distributed framework, we can improve the computational efficiency. And data pre-processing. Use techniques like data dimensionality reduction to reduce the data size before training. And the PCA, principal component analysis, and SNE, these are example for dimensionality reduction techniques. And next is model pruning and quantization. Actually reduce the size and computational demands of model through pruning. Pruning means removing the unnecessary weights so that the model become less complex. So reduce the size and computational demands of models through pruning or quantization. Quantization means reducing the precision. And edge computing. Deploy lightweight models on edge devices to offload computation from central servers. That means to reduce the load of the central servers and give the load, share the load among the lightweight models, edge devices. Actually, sharing the load of central server among the edge devices, so that the complexity can be reduced. And next, using a efficient algorithm. Instead of using single model, we can combine several models and we can get the aggregate result of those models. So the computational efficiency can be improved. So some of the techniques are used for improving the computational efficiency, and some of the techniques are used to improve the scalability. Next is generalization to new data. Actually, the model is work well for trained data, but whenever it see the new unseen data, the performances automatically degrades. So how to address these issues? So ensuring that the model generalizes well to unseen data, especially in case of distribution shift or concept drift. The solution is cross validation. So use cross validation with a hold out test set. In k-fold validation test. So using the cross validation, we can improve the generalization. And next is regularization and dropout. Dropout means we are removing some of the layers to reduce the complexity of the system. So use dropout and other regularization techniques to avoid overfitting to the training data. So using regularization, we can reduce the overfitting or avoid overfitting. So both the techniques, regularization as well as dropout, both are used to avoid overfitting to the training data. And next is domain adaptation. Actually, the techniques such as transfer learning or domain adaptation to adapt the model to new domains or data distribution. Transfer learning means that we are having a pre-trained model. So the pre-trained models are used for some other application. Now we are using the transfer learning method for new domain. So apply techniques such as transfer learning to adapt the model to new domain or data distribution. The same pre-trained model is used for new domains. And next is data augmentation and diversity. Data augmentation means enhancing the existing data set by applying some transformation. So by introducing variability into the training data, the model is forced to generalize better. So by improving the number of samples, we can able to generalize the model. Online learning. Continuously retrain the model with new data to adapt to changes in the environment or data distribution. So we have to retrain the model with every time new data so that it will adapt to unseen changes easily. And next is hyperparameter tuning. Actually, this hyperparameter tuning takes place at the time of validation. So identifying the optimal hyperparameter actually to identify the parameter itself take computationally expensive and time consuming. And how to address these solutions? The hyperparameter tuning is either done with a grid search or with a random search. So search the hyperparameter space using brute force or random sampling to identify the best combination. And next is Bayesian optimization. Use probabilistic model to guide the search for optimal parameter more efficiently. So Bayesian optimization is another technique to optimize the hyperparameter value. And next is hyperparameter auto tuning. So it will automatically tune the hyperparameters. So use techniques that automatically tune the hyperparameters. And the last one is early stopping. Actually, stop hyperparameter search when performance doesn't improve after several steps. Suppose you are changing the hyperparameter continuously, and if there is no change in the performance level, we will stop the hyperparameter tuning. That is referred as early stopping. Okay, next one is real-time decision making. So taking real-time decision is very tough. So how to address these issue? Low latency model. Some of the example for those models are decision trees, linear model, and smaller neural network. They will take quick decision. So use models designed for speed such as decision tree, linear model, or smaller neural network that can make quick decisions. So for real-time decision making, we have to use the quicker model. And next one is model compression. If the model is too complex, it will take time to take decision. So we will reduce the size of the model to enable faster inference. தாமரை தாமரை தந்தை நான் இப்போ இதில் இருக்கு கொஞ்சம் அனுப்புறேன். Hello? Hello?
Yes, ma'am.
Okay. And next is model compression. Reduce the size of the model to enable the fast inference. So we will reduce the complexity so that the speed will increase. Next is edge interference. Edge inference. Perform inference on edge devices to reduce latency. So we are using mobile phones and IoT devices to get inference so that it will reduce the latency. And next is caching and pre-processing. Pre-process the data and cache results when possible to speed up response time for real-time decision. So we will store the results in cache memory so that the response time will be reduced. So pre-process the data and store the results in cache memory so that it will speed up the real-time decision. And the next one is algorithm selection. Actually, there are three types of machine learning: supervised, unsupervised, and reinforcement learning. So, depending upon the application, we have to choose any one of the algorithm. So, how to choose the correct algorithm? The solution is model benchmarking. We have to experiment with different models and benchmark that performance on validation data. So, we have to experiment with the different models and compare their performance on the validation data. And next is automated machine learning, auto ML. Actually, auto ML means it is a framework which automatically select, tune, and evaluate the best model. So it is a framework that will automatically select, tune, and evaluate the best model. So the machine itself chooses the correct algorithm. And the next one is model comparison. We have to assess the algorithm based on their interpretability, performance, training time, and ease of deployment. So, considering these features, we have to compare different algorithms, and depending upon the need, we have to choose any one of the algorithm. And next one is hybrid models. Instead of getting result from a single model, we will combine multiple model to improve the accuracy and robustness. Using multiple model is referred as ensemble methods. And the last one is resource constraints. Due to the limitations of computational resource, memory, and storage for model training and deployment. So how to address this issue? By using cloud services, uh, we can use the resources from cloud. So use cloud-based ML platform that offers scalable computing resources on demand. So the resource limitation can be addressed using cloud services. Some of the example cloud services are AWS, Google Cloud, and Azure. So using this, we can fix the issue of resource limitation. And next is model compression. Using model quantization, pruning, and distillation, you will reduce the model size. Using the technique of model quantization, pruning, and distillation, you will reduce the model size and memory requirements. And efficient framework. So using the framework like TensorFlow, PyTorch for efficient deployment, especially for edge or mobile devices. So using efficient framework, the resource constraint can be reduced. And next is distributed training. Distribute the training process across multiple machines to use specialized hardware like GPUs, TPUs, or FPGA to accelerate training. So the training process is done across multiple machines with a specialized hardware like GPUs and TPUs. Thus we can address the issues. So machine learning has revolutionized the way we analyze the data and make decisions. It provides the ability to uncover hidden patterns in the vast data set, enabling us to create predictive models that can transform industries from healthcare to finance and beyond. As it continues to evolve, it is important for practitioners not only focus on improving accuracy and performance, but also address ethical concerns, fairness, and transparency. By overcoming these challenges, we can unlock the full potential of machine learning, enabling smarter decision making, driving innovation, and improving life across the globe. Hello?
Hello, ma'am.
Hello, sir.
Yes, ma'am.
That is the end of the session, sir.
Okay, ma'am. Okay. Okay, ma'am.
Okay, sir.
Thank you for your valuable presentation, ma'am. Thank you.
Thanks, sir. Thanks, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Okay.
Shall I leave, sir?
Leave, ma'am.
Okay,
Leave. Yes,
thanks.
ma'am. Yes.
Thanks.
Okay.